In this topic, we'll connect Luna HSM concepts to real TLS and PKI workflows. You'll see how HSM-backed keys support TLS termination, certificate issuance, and lifecycle management, and how they plug into web servers, load balancers, and existing enterprise infrastructure. You've already built a solid foundation. You learned how Luna HSMs are structured, how partitions, roles, and clients work, and how trust is established. Then you moved into key types, attributes, lifecycle management, and PKCS number 11 integration patterns. Most recently, you used those keys for encryption, decryption, and digital signatures. Now we'll turn that capability into real infrastructure value by wiring HSM-backed keys into TLS and PKI, and then finish with operational best practices. TLS and PKI are only as strong as the private keys behind them. If a TLS server key or a CA signing key is stolen, certificates, sessions, and entire trust chains can be impersonated. Luna HSM changes that risk model. Keys are generated and stay inside hardened hardware, while servers and PKI components send signing and decryption requests to it. Because the private key never leaves the HSM, you gain stronger security, easier compliance, and cleaner audits. In any TLS handshake, the core question is, can the server prove it really owns the private key for this certificate? First, the server sends its certificate chain, and the client checks that chain against trusted routes and intermediates. When it's time to prove possession of the private key, the TLS stack calls into the Luna HSM. The HSM performs the signing operation, while the server software continues handling all other TLS messages and session setup. In this design, the TLS endpoint still manages the handshake and presents the certificate to clients, but it never holds the private key directly. Instead, it's configured to use an HSM-backed key. When a handshake needs a sign or decrypt, the Luna client forwards that operation into the HSM. The key stays non-exportable in a secure zone, while you tune termination placement for latency, throughput, and operational ownership. Integrating a TLS platform with a Luna HSM really comes down to choosing the crypto interface that fits your ecosystem. OpenSSL typically uses an engine or provider, so you focus on engine paths and label mapping. Java stacks plug in through JCA and a Sun PKCS 11 provider, with key store and alias configuration as the main tasks. Appliances usually ship a vendor connector you enable and point at the HSM. Custom applications often go straight to PKCS number 11 for maximum control and performance. When you move TLS keys into the HSM, think in 4 steps. First, verify that your TLS stack is actually using the Luna library or connector, because if that fails, everything else breaks. Second, confirm the service account can authenticate to the correct partition. Third, reference the key by a stable label or alias and lock that name down. Finally, validate the entire certificate chain in a test environment before touching production traffic. When TLS is backed by an HSM, the bottleneck is almost always the private key operations during the handshake, not the data transfer afterwards. Your goal is to minimize how often you hit the HSM. Session resumption, TLS 1.3, and long-lived connections all turn expensive handshakes into cheaper resumptions handled mostly by the CPU. Measure this with realistic tests: handshakes per second, P95 latency, concurrency, and HSM utilization during peak connection spikes and certificate rotations. Once TLS termination depends on HSMs, availability becomes as important as security. Think in layers. Your TLS nodes should be stateless and able to fail over quickly between HSMs in a Luna high availability group. Client libraries must retry intelligently so a single HSM outage doesn't look like an application failure. Remove every single point of failure: hosts, HSMs, networks, and load balancers. Then make sure certificates, keys, and HSM access are fully covered in disaster recovery plans. The lifecycle really starts when you generate the private key inside the Luna HSM and never let it leave. Next, you create a CSR that proves you control that key, send it to a CA, and receive a certificate and chain. You then associate that certificate with the correct HSM key and deploy it to your applications. From there, you continuously plan renewals, rotations, and eventual revocation or retirement to avoid outages. Here's how that looks in practice. You select the HSM key by label, provide the subject and all required SANs, then call the CSR command using the HSM provider. The HSM signs the CSR internally, proving you control the private key, but never exposing it. Finally, you attach any required metadata and submit the CSR to your CA. After your CA issues the certificate, wire it to the correct HSM-backed key in your TLS service. Then load the full chain, server certificate plus any required intermediates in the order your platform expects. Remember, certificates are public objects. The private key never leaves the HSM. To finish, test from the client side using a browser or TLS scanner to confirm the chain, hostname coverage, and expiration all look clean. You can think of Luna HSM as the enforcement engine for your PKI policy. Start with the rules. Who may request which certificates, for what purpose, and under what approvals. Then encode that in workflows and certificate profiles so server, client, code signing, and CA keys are clearly separated. Finally, configure the HSM so keys are non-exportable. Operations are restricted, roles are separated, and every key and certificate event is fully audited and owned. At the enterprise level, Luna HSM becomes the trust anchor at the center of your environment. Your CAs send key operations into the HSM, while certificates and policies flow back out to load balancers, API gateways, and ingress controllers that terminate TLS. Automation pipelines handle CSRs and renewals end-to-end without exposing private keys. Meanwhile, health, audit logs, and certificate expiry signals stream into your SIEM, so operations can monitor and respond. You've now seen how Luna HSM anchors TLS termination, keeps private keys off the servers, and drives certificate lifecycle tasks like CSRs, renewal, and rotation. You also saw how PKI policies, audits, and ownership tie in. Next, we'll harden this design with best practices, testing, and troubleshooting.